Hello, it's Craig from fixitfallows, and yes, again I'm in the garage. And today I'm dealing with my trolley jack here. This is a cheap Chinese trolley jack, which is a common theme there with me, cheap and Chinese. I know I'm a glutton for punishment. Now, I don't use a trolley jack very often, hence I didn't spend a fortune on one. But when I do want one, I want one with a bit of lifting capability, so this one's 2.5 ton. And I don't know if you've seen these type. Let me show you a bit of a close-up. There you go. It's quite a low profile one, so you can get it underneath lower slung cars as well as 4x4s. And the way this one operates, you have the jack there that goes down into this kind of, what do you want to call that, some sort of shank there. That does the pumping, like so. As you can see, it's going up. And then when you want to release it, you rotate the handle that goes down into there, and that engages with a hex shank that's universally jointed down into there, into the valve that controls hydraulics. So when you want to lower it, you rotate the handle, the pressure falls, and that goes down. But what I've been finding is that I'm jacking up, and no matter how much I rotate this handle, the pressure isn't dropping. And then closer inspection shows that when I rotate this, the sort of hex shank and UJ is not turning, so something has been going wrong in here. So if we take the handle off, you just, that locking nut comes out of there, you can lift the handle out, and then at the bottom of the handle is a hex socket, but it's only got about 3mm of depth to the steel there. That is a bit chewed up because I've been attacking it a bit, but basically what happens is that starts to rotate on that hex shank there, and because it only engages with about 3mm of steel, it cuts into that hex shank and doesn't engage anymore. So left me scratching my head. So I can just use a socket like this to go down there and disengage it, but depending on how you've got your vehicle jacked up, makes it rather difficult really to take the handle out every time and do this. So it's not ideal. So what I'm thinking is I am going to drill out the end of here as best as I can, take this deep socket which would engage nicely with that hex shank in there without cutting into it. I'm going to open this aperture, open this aperture here as much as possible, drop this socket in there, and I'm going to weld it in, creating a new socket for the handle to go down and engage with, and that should fix my problem. Okay, right, so this socket that I want to set in the end of there, that's a 14mm sort of internal hex there, so the outer side of that is got to be what, somewhere like 17mm, so we've got to try and make a 17mm aperture in there. Now as you can see, I've been attacking it a bit. In an ideal world I would sort of mill it out, but I cannot. One, I haven't got a mill bit quite big enough, and two, I cannot get the full length of this handle into any machinery I have to mill it out. Ideally, other than that, is putting it on a lathe and cutting it out, but again, one, I don't actually have a lathe, although I know people who have, but they haven't got a lathe with a big enough bed on it to take that whole handle. So I've been attacking it with various things. I put some metal bits in my jigsaw and I've just been cutting as best as I can. And then finally I'm attacking it with my metal file, and the metal file is actually having some good progress, so I'm going to continue to file this away, and I shall show you what progress I make. So there we go, I've been filing for about 5 or so minutes, and I've got to that stage. So it seems to be working with the file. I shall carry on and get that fully opened up and rounded. Okay, so now I have filed that right out. I can now take the socket like this, and the socket now fits in there. And now the plan is to weld that in there. What I do need to make sure is that there's enough depth in there. I might have to slice off the end, because I think as this pivots you do get some movement on there. So what I don't want is for that shank in there to bottom out on the top of the socket. So I may slice this off so it's effectively just an open tube to give that shank as much movement as it needs. Okay, so before I start trying any welding, what I'm going to try and do is drill 3 holes, one here, one here, one here. I'm going to drill them holes out, thread them, and then put 3 corresponding flat spots on the side of the socket, and see whether I can't hold that socket in place in there with the screws. Now I will then have to grind the head of the screws off so that it fits down into the pipe there, but that may well be sufficient, we'll see. If nothing else, what that will do is hold the socket in there nicely so that I can then put a bit of a weld around there. Okay, so I've drilled out the holes and I've now started to tap them out like so. Then I can thread in a screw like that, and I'm going to do the same on that one and that one. There you go, like so. So now I can try and fit the socket. Okay, so I've dropped the socket in there, held it in place and put the screws in, and as you can see, so far so good. What I've then done, I've taken out individually, I've taken out each screw in turn, and having already put some masking tape around the socket, I've poked through and made a mark with a pen so I know where to put the flat spots on the socket. Okay, now I can take all the screws out. And there you see the markings on the side where I need to grind down some flat spots. Okay, so there are a few flat spots ground onto the side there, just done that on my grindstone. That should be enough for those teeth, just the screws just to hold that socket in place. We'll give it a go. Okay, so there's the socket in place. Screws are all in place. I've done them up as tight as I can. I'm just going to give them a final little nip. Like that. Now all I've got to do is cut these screws off and smooth off those spots so that this can rotate. So there we are. The screws have been sawn off and filed down, and the socket is firmly inside there. So now we can drop that in there. As you can see, the valve adjustment is rotating. Put my locking screw back in like that, so the handle can't come out but it can still rotate. So let's put the rest of the handle back on. That goes in there like that, a screw goes in there. So the handle is all fully back together. I can twist it to undo the valve. I can twist it to do it back up, like so, and I can pump. So up it goes. The valve's fully done up. And then I twist the handle, it goes back down. That seems like a fairly successful fix on my 2.5 ton trolley jack. Time will tell how long it lasts, but the next option is to weld it in place, and once it's welded in place I can't see it causing any further problems. But for the moment those screws seem to be holding it. I don't use the trolley jack all that often, maybe once or twice a month. So obviously if you're using it for commercial reasons it won't last, but if you're commercial you would own this trolley jack anyway. So anyway, thanks again for watching. Please check out some of my other videos, subscribe and make sure you hit the notifications, and thanks for watching. See you again soon.